Hi, welcome back again to my YouTube channel. My name is Ibuka, and with today's class, we're going to be talking about the sine rule. And the sine rule is a very important concept in trigonometry and in geometry. And depending on what you're looking for, right? And I'm also going to, in this section, I'm going to be explaining when and where to apply the sine rule. So the sine rule technically states, mathematically states that when you have, for a given triangle, whatever the type of triangle is, that the sine of, let's say, A all over, sine of A, this angle, all over the side is equal to the sine of B all over B. Remember, it's very important that you make reference with, for an angle, the sine of an angle is all over the side that is facing that angle. Then in this case, I also have sine of C all over C. So in essence, the sine rule establishes a relationship that the angles of a given triangle has with their respective sides. So in this case, this is what the sine rule is all about. And we're going to use this. Let's see how we can use this and solve this problem that we have on the board so that we can understand what it's talking about properly. So this is a given triangle, and we are required to find y and s. Let's also make it more interesting. Let's also find z. We're going to find the side, the length of the side, right? So based on what has been given, we are going to find the respective sides, and let's see how it works out. So to find that, we're going to apply the sine rule. And the sine rule states that sine of 30 all over 5 meters must be equal to the sine of x all over 2. So this is what the sine rule is saying. And now, because of what we know, I can just make sine of x is equal to, because multiply, 2 sine of 30 all over 5. But I know that from the function that we've done previously, that sine 30 must be 1 over 2. And sine x is equal to 1 over 2, which is the same thing as saying 0.5, but let's say 2 times 1 over 2 all over 5. This into this will give me 1, right? So that x is equal to the sine inverse of 1 over 5. The sine inverse of 1 over 5. Just hope you can see this. In today's course, we're going to be talking about cosine rule and how to apply it and when to apply it. On the board, we have the diagram, and just to explain what it means without wasting much of our time, a cosine rule is a principle that states that for a given triangle, right? Let's say we're working with A. Let's work with this angle, assuming that we know the value of this, right? It says that if we want to get a square, okay, let's work with c. C squared, this, right? As long as I'm working with this, then I can then say that a squared plus b squared minus 2ab cos. So the angle that I must use here must be this, the large C. In this case, this. So why am I saying this? It is very important for you to understand the relationships. When I'm looking for this, it has some similarities with Pythagorean theorem, but if you pay close attention, this was added. So just in case when you're looking for any side, let's say, for example, let's say we're trying to find A, right? Then a squared must be, if I'm looking for this, that means I'm considering this angle. Then it has to be that c squared plus b squared minus 2a 2cb cos a. Yeah. And then if I'm looking for b, it means that a squared, I'm looking for this, right? I'm considering this angle. The opposite sides is what I'm making use of. So I'm making use of a squared plus c squared minus 2ac, then cos of b, because that's what I'm looking for. So basically, that is how this applies. And we're going to make use of this principle that we've already stated that shows the relationship an angle has with the side of a triangle, well, respective side of the triangle. And then we're going to use it and find the value of s. So without wasting so much of our time, and this diagram requires that we find s, so we're going to just go straight ahead and impute the values. So from this, what we've done so far, we know that s squared, applying the cosine rule, that s squared must be 4 squared plus c squared minus 2 times a times b cos of 30. And if that is the case, then s squared is equal to 4 squared is 16 plus this is 36 minus 2 times 4 times 6 cos, of course we know what cos 30, cos 30 should be adjacent of our hypotenuse is root 3 all over 2. And then to break this down further, we have this should be 52 minus this and this goes, so that 4 times 6. 4 times 6 is 24. 4 times 6 is 24, so I have 24 root 3. Again, x must be equal to the value of 52 minus 24 root 3. Once you punch this in your calculator, this should give you the final answer. Like we've seen, I'm going to drop the value so that you understand. And whatever I get, the answer should be in meters.